Okay, I think we're set.
我想不到任何理由要去，因为没有开抗，我需要干嘛？
为什么没有他的抗？有
无数个人告诉我，
啊？
无数个人告诉我已经没有开抗，
你说 new graduate？
而且我投了一个看，也没有消息。
你投了一个？
对，因为他没有开抗，我
new graduate 没有他看。
没有他，最虚呢，因为好多人都是。然后我投了一个看，并没有人鸟我。这公司就这样子。
Yeah, I'll try. One of us, the two of us.
你投 intern 是要
The two of us
延
will
毕
try.
吗？
等过了再说，不过
我有一个同学是给 track 他已经拿到 intern 了，他是给 track C， 然后他转码嘛，他已经拿到 intern， 所以是转码。
Is it okay to drive?
Facebook 就是太强了。
这么点，不过他读地面的挺快的。
啊？
我说地面的挺快的，主要是。他那个是挺快的，但是你说学生啊，这个也太快了。
对，所以很快。但是那 FB 的 intern 一般是什么时候？日文不是1月份才拿到的。1月份怎么？
说错了，村长。1月份是村长。你以为呢？
村长还有这个抗拒。
我就这么跟你说，1月份的话你一定要面，那会儿面膜基本上往后转就是减肉。4月份，1月份差不多就是4月份。你要问什么？
不是啊，那你FB投了之后多久能收到面试？然后想1月份得到面试。
以后投了2月吧。
还没有。
不，
有还没有消息。
8月投的有。但我
但他可能是 new graduate。
对。在他面的时候已经没有你旁边的是什么？主任题我有想法。
All right, so let's get started. Can someone check? Is the camera recording? Yes. All right. Sweet. So, welcome back, everyone. How is week 4 going? Thumbs up. Okay. Thumbs down. Okay. All right. So, I slept at 5 last night, and I just had a midterm. But I am super pumped to teach you all about templates. Alright, so let's see. So first, go to the 106L website and download the Qt file. Based on some of your feedback, we're going to do a little bit more like interactive kind of teaching, which means we'll be doing examples, but then I'll also ask you, okay, try coming up with this function on your own. Okay, so I encourage you to download the Qt Creator file. If you don't have your laptop, that's totally fine.
Find a partner and look on it.
Yeah, find a partner. All right. So while you're doing that, let's just quickly talk about this. So based on your feedback, which we will talk about, for today we'll mostly not be using slides. Okay. I'll motivate everything using code. So yeah, the slides are important as a reference, but you don't have to follow it necessarily during the lecture. If it helps you, you can put the slides on there while I go through the code. Okay? Nod your head if that is okay with you. Even if you shake your head, I'm not going to do anything about it today. All right. So, by the way, just a summary of the feedback. Here, so some of the likes you guys mentioned, engaging. The slides look nice. Thank you. We spent a lot of time on the slides, so thanks. We really like making slides. Someone said we're, quote, nice. So I don't know what that means, but hopefully that is not sarcasm. Some people people say the class is really chill, and it is really chill. It is supposed to be a chill class. You're not supposed to be stressed throughout this class, okay? And it also, some people really like the amount of questions that are asked during the class. Some dislikes, some people think that the class is a little too fast, a little too much content, too many slides. Yeah, unfortunately. Some people want more practice, so in addition to the assignments, maybe more like practice questions, more interactive lectures, which we'll definitely start today, and some people don't like the amount of questions. All right, so here's a summary of like some of the changes that me personally, I'll be making on this lecture. So for today, I'll post a couple practice exercises on the Piazza if you want to practice. Okay, I've scaled back this content and slides of today by 30%. Okay, but the slides are still in there. It's just I'll skip over them. All right, so you'll all get to see what you missed. And then today we'll be doing some time to work on your on the questions, but you'll also have time to ask questions during that time. All right, so hopefully that will even out the balance between questions and okay. Any questions? Okay. Oh, and more than one person mentioned that I should throw candy. So I brought candy. All right. And I think what I'll do is whenever I stop for questions, I'll grab like a few pieces of candy, and then we'll keep asking questions until the candy runs out. And that when the candy runs out, that means it's a sign for us to move on. Okay? Seems fair? All right. I haven't really practiced this grabbing candy thing, so I might grab too many. Just saying. So here's a roadmap of what we've been covering so far. We are going through the standard template library. Today we're going to enter this little bubble called templates, and you can see that it's part of a larger bubble called generic programming. Okay, so there are a couple paradigms in programming. What's one kind of programming you've heard of? Okay, so I hear object-oriented programming. Yeah, so that's like one of the biggest buzzwords in Java, because Java is a object-oriented programming language, and that's mostly what you've been used to so far. Right? Any other like these paradigms that you've heard of? Yeah.
Functional?
Functional programming, yeah. So C++ does have functional programming capabilities, but we're not going to be covering them because, in my opinion, I think there are more languages suitable for functional programming. Okay? Yeah. Programming paradigms are essentially like different ways of approaching problems. One way to approach and break down problems is to break them down into classes, visualize these things in CS as like objects. That's why we call them object-oriented programming. And that is a big part of the class. We'll be covering how C++ implements object-oriented programming. All right? But there are other kinds of programming. One is called procedural programming, right? And that's kind of what is done usually mostly in C, right? C is basically, okay, here's an instruction, do this, do that, do that. That's called procedural programming. What's cool about C++, people call it a multi-paradigm language, is because it combines all these different paradigms. You can do procedural programming, that's why C++ is derived from C. You can do object-oriented programming, we'll be talking about classes very soon. And then there's this third kind, which is called generic programming. And that is something which you might not have even thought, like when you took the class, you probably weren't trying to, you probably didn't think to yourself, oh, I'm taking this class to learn generic programming. But generic programming, I believe, is like one of the most unique parts of C++. Other languages have generic programming. They have capabilities of templates, of all sorts of stuff. But I think C++ has a very unique set of tools for generic programming. That's what we'll be covering. We have 4 lectures on like generic programming, kind of. Today's the first one. And then on Thursday, we'll be covering functions and algorithms. Okay? Now, you might all think, yes, I know what a function is, I know what an algorithm is. But that class is very important. Make sure you complete that class. Okay, today we'll be covering template functions. So that's the first thing we'll talk about. We're going to skip over erratic templates, which is something which I find really cool, but we don't have time to cover. So, but the slides are in there. Concept lifting, which is an important discussion, reason to motivate why we want template functions. And then we'll talk about implicit interfaces and concepts. This will lead directly into our discussion on algorithms and functions next week. Okay, so I'm going to switch over. We're not going to do slides anymore, and we're going to talk about template functions. Let's see, how do I zoom in? File, command, what? Oh, there we go. Okay. So, we're gonna, the first function we're gonna write is we're gonna write a function called MyMinimax, okay? Now, I really wanted to call the function minimax, but unfortunately, C++ has a minimax function. We are gonna implement that function basically, but instead I'm gonna call it MyMinimax, okay? And essentially how MyMinimax works is you give it two parameters, let's say A and B. So, and then for example here we say MyMinimax 3 and -2. And then what it should return is it should return a pair where the first element is the smaller one and the second element is the bigger one. Alright, pretty straightforward so far? Okay, so just as a quick test, can you all see this? Okay, what should min1 be? -2, max1 should be 3. Okay, great. You can all compare numbers. Great job. Okay, so that's essentially what this function is doing. And then I also, just to make the code cleaner, I wrote this function print min and max, which takes in the min and the max, and it prints out min is this. So if you run it, it does exactly what you think it does. And just to prove it to you, let's see it. Oh. Min is -2, max is 3. If the two numbers are the same, it doesn't matter which one's the min, which one's the max. Okay? Any questions so far? Okay. So, okay, let's quickly talk about this. So, this function is great for integers, right? But what if, say, I wanted to do something like, let's say, this. Also, Qt Creator is not the most up-to-date, so it doesn't recognize, when you, the auto indent, it doesn't recognize structured binding as a valid thing. So that's why you'll see weird auto indents. Okay, what if we wanted to do something like this? Max of 8.3 and 7.4. So this doesn't work. Anyone want to guess why it doesn't work?
Double instead of int.
Yeah, you want a candy?
Yeah.
Alright, so yeah, because 8.3 is a double, that's not an int. Now you can see it will still compile. It gives you a very severe warning. Yes, you're trying to do a double to an int. But it will compile. Guess what it prints? Yeah, it prints 8 and 7. It basically casts these as ints, and then it just tries to do it as an int. Okay, definitely not what you want. Okay, so, yes?
When it says implicit conversion, does that mean that when it compiles, or is it at runtime when it looks at the double, turns it into an int, and then gives you an unexpected result?
Yeah, so implicit conversion is done at compile time. Compile time. So when you press run, when it's compiling, it sees, oh, you're trying to call double to an int, so it will do the conversion for you. And then during runtime, you see that, oh, it's not printing anything.
So alternatively, they could have put an error so that we are aware of it.
Right. Yes, exactly. So C++ could have put an error there, but remember one of the key philosophies of C++, right? What was the philosophy? Yeah, essentially give the programmer full control, and if they want to do whatever they say they want to do, even if it's wrong, C++ will let you do it, okay? Well, yeah, one big thing about templates is it will do compile time checking for you. If you type in something wrong, it sometimes will figure it out and tell you, hey, that's not what you're trying to do. Okay, question, yeah?
I know that this is an implicit conversion, it will work, but what happens if you pass in this string 8 and this string 7?
Good question. Hey, so, coincidentally, I have these things over here, so let's pull it out. Okay, so you can see here that, let's say, suppose we try to do characters. So technically, characters can be converted into ints, so that's not a problem, even though it's still kind of weird, but you can do that. If you try to do strings, well, that doesn't work, right? Strings can't be implicitly converted to ints. Okay, so without worrying about what templates are, if you did not know anything about templates, how would you tackle this problem? Anyone want candy? Yes.
We can make it a function and pass in a comparison function to compare any two elements of.
Pass in a function. Okay, so you're saying we pass in a comparison function?
Yeah.
Okay, that's a little bit more advanced. We'll get to that next week. But yes, we will get to that very soon. That's a little. Let's pretend you didn't know about it. Yeah, that will require templates as well. So let's not get to there. But yes, you're definitely right. That's what we'll do next week. Yes.
Oh, does it qualify for a candy?
Oh yeah, what kind? Sure. You want Reese, almond, Kit Kat, and Hershey's?
It's cat.
You want a Kit Kat? Oh, you want a Kit Kat? What do you want to add? Okay, just gonna throw your Reese. Yeah.
You could overload that MiniMax method.
Sure.
MiniMax method, so then have one for strings, one for doubles, one for.
Sure. Okay, that is a great idea. And this is what you would do in C. If you were coding in C, if any of you are taking 107, you will do this. Where, okay, since that function doesn't work, let's write a function for strings. And then, how would you write the function itself? Yeah, so if A is less than B, you can compare strings using the alphabetical comparison and just return AB, else return A. Okay? Cool, so that solves this one. Yeah, that solves this one. We're gonna have to do the same thing for print minimax, so let's not do that. But, and then how would you solve this double one? Yeah.
Maybe like an alternative approach, could you have auto declare your inputs for your functions auto and then just and then compare them?
Interesting. So you're saying like make these auto?
Yeah.
Yeah. That's a good question. So auto can be used in many places, but one of the places it can't be used is the parameter. Yeah.
Okay.
So yeah, so that's a very good question where essentially you can't really put auto here. You'll get like an error. You can put auto in the return type. You can put auto everywhere else, but you can't put auto in the parameter. But what we're going to be doing, templates, is kind of like putting auto in the parameter list. All
Can I
right?
have a candy for that question?
Yes, of course. Right, so,
Kit Kat.
okay. Oh, also, so I'm going to point at you, and if you don't say what you want, I'll just throw something random at you.
Reese's.
Okay. Don't hit my phone. Sorry. Okay, I also want to make sure you're all like alert. Okay, so yeah, that's a good question. So how do we handle this for doubles?
Same thing.
Same thing. Okay. Okay. You know what? I'm just gonna copy paste this.
Could you like just replace the int on MyMinimax the first thing with doubles and just because wouldn't like just replacing the ints with doubles on the very first thing accomplish the same thing?
Yeah. So that's a yeah, that's a good point. So actually, the slides are really beautiful. So I'm going to okay. So this is what we wrote, right? Actually, okay, this is what we wrote. By the way, sometimes you'll see this where for each function you call, okay, this is for the int one, this is the double one, this is the string one. This is horrible because then you have to actually write int in the function.
Why would you? Oh, in C you have to do that because you can't overload.
In C you can overload. Yeah, in C you can overload, but like this is like the most like basic. If you do not know about overloaded functions, you can do like this.
And sometimes for style, which is
I think. Okay, I'm not gonna talk about the wood stars, but that is where one place you use it, right? Okay, yeah. So yeah, this is what we wrote, right? Okay, what do you notice about these?
they're so redundant.
Okay, they're redundant, right? Okay, let's see. Okay, so here's an observation, and this is why I'm gonna slides because it looks really nice. Notice the highlighted parts. What do you notice? They're the exact same. Like it's not just similar; they're the exact same. The only difference is the types. Alright, so let's just do what you might naturally do. Okay, let's just call them T. Okay, if I replace them with T, what do you notice about the whole thing? Everything's, yeah, so let's just collapse it into one. And there, that is a generic function. Now, the thing is C++ doesn't know that that's a generic function. It looks up the type T and it thinks, oh, what's T? I don't actually know what T is. So you have to actually tell it, oh, this is a template. Right? And there you go, templates. Templates are very complicated, but the most basic form of a template, there you go. We're telling C++ that we're declaring a template function, which has as the different like template variables. We have a template called T, and then we have just different places where we put the T. Yes.
Are there things that you cannot templatize? Like for example, like operators. Like, templatize an operator.
You can templatize an operator. Yes, I think you can. but I think that's actually how they implement. There's some really advanced C++ things that they implement using templatized operators. We'll get to operators 2 weeks.
But like in general, are there things that you cannot templatize?
You can templatize lambdas, you can templatize classes, you can templatize. Am I missing anything? There's a lot of things you can templatize. We'll go through a lot of them, but can't think of something. I mean, you can't templatize a variable. Although, yeah, those kind of are. So yeah, I'll get back to you on that one. I gave you a
Yeah.
so let's take a break. Yes.
Can you put something besides for T there? So like put B instead?
Sure.
Or
And-
not B in this case, but lowercase t.
Awesome question. So let's segue into typing the code and let's try that. All right. So template, type name, and then just for fun, let's call it. What do you want to call it?
Lowercase t.
Okay. Sure. Okay. And then here we would say, okay, instead of the int, let's put the t. Let's put the t there, and then we don't need any of these. Yeah, that works. All right.
Braces.
This is gonna be hard.
Right.
Oh wow.
Hey.
Wow.
Perfect.
And one other note about that is actually that a style thing that people will tell you once you've learned this structure is that you'll actually want to name your type name something that like provides info to the person reading it. So like type name, so you can name it whichever sort of variable name that you want.
Yeah. Although I'm just gonna name it T, but we will name them something more informative later, because later we're gonna deal with multiple ones. So you don't want T. What's the letter that goes after T? U. T U V W. Yeah, you don't want all that. So just as an example, we're gonna put T right now, but later we'll name them with something better. Yes.
Yeah, so I have a question. If you try to templatize a custom struct that isn't comparable, then will it not work, or just will we get like some weird behavior and try to compare the two?
That is a great question, and that is something we'll cover in 30 minutes. No, not 30 minutes at the end of the class, 20 minutes. Yeah, that has to do with something called implicit interfaces and concepts. But you bring up a really good point, right? This function assumes that you can compare a T with another T. Okay, but there are some things you can't actually compare. So we'll talk about that. Candy?
Sure, yeah.
Nate?
Anyone.
Okay, no one likes these, so I'm gonna give you this. Do these have, so,
They're so good.
they're tasty. Okay, wait, so if you have a nut allergy, you should not eat this, correct?
Yes.
Okay,
They have actual nuts.
I'm good at all these, yeah.
you're good? Okay. Okay.
What happens if like A is a double and B is a
Great question. We'll cover that in 5 minutes.
Alright.
Candy?
No, I'm good.
Okay, yes.
So how long is template T defined for like, for print min and max? Can I use T as well? Or will I have to say template type name T again?
Good question. I think, and correct me if I'm wrong, I think you can only use this for this.
Yeah, you have to redefine it for every function.
Yeah. Although I'm not. Yeah, I think because this is a function template, so it's defined for the function that immediately follows it. When we get to class templates, you can use it the entire class. Yeah. Candy?
Sure. I'm gonna do it.
Okay. When I say candy, you have to immediately say what kind of candy you want. Otherwise, I'll just throw you something. Yes.
Does this have features similar to Java generics where you can like specify like it will only take certain things in?
That is a great question, and we will cover that soon. That has to do something called concepts, which is a C++ 20 thing. We will get to that. Yeah. So in Java they call it like interfaces, or I'm not super familiar with Java. What do they call it in Java?
I think interfaces.
Interfaces, right? Yeah. So yes, there is something similar, but we'll get to that very soon. You're asking really good questions, which are what I'm going to cover soon. So, any other questions? Yes.
So, could you go a bit further into what the line means? It looks like type name is like the variable type, and then T is a variable of type name. But what's template?
Good question. So template is essentially just declaring, okay, what follows is a template. Okay. And then type name means whatever, we're templatizing this using some type. Yeah. You can actually templatize it using like other types. So this is saying, okay, T is a size. T. You can say which is something you'll implement in assignment 3. You can templatize it using values as well. But we mostly, for templates, we mostly are templatizing it using types. That's why we say type name there. For type name, that means you can put ints, you can put doubles, you can put custom structs, you can put anything in there. Later we'll see, we'll get to class, which means T has to be a class. So int double would not work. Did you want candy? No? Candy?
Dark chocolate?
There's no dark chocolate.
Kit Kat then.
Okay. Yeah. Okay. Can we move? Let's just finish the code and then let's have more questions. Okay. Yeah. This whole thing is not working. Can we get a rule? You can only request candy that's on the table right now. Okay. Let me finish the function. Okay. So we templatized it. We have to templatize this as well. So T, and almost all of them work. Let's try running it. All right. What do you notice? So min max, great. Min max, great. Min max, great. Min, yeah, B is less than L. Is this correct?
No.
Which one is alphabetically first? Yeah, so Anna should be min, and then Avery should be max, right? Weird. Okay, but I'm not gonna tell you why. Let's first talk about instantiation. Okay, so what is instantiation? Let's use slides, because the slides are really pretty for this one too. Okay, so there are two ways for when you call MyMinimax. The most clear way to basically specify what T is this is called explicit instantiation, where you explicitly put the type in brackets that follow the function. Okay, this notation you've probably seen something similar when you try declaring like a vector, right? When you declare a vector, you put the type inside. So you can probably guess vector is a template as well. Here, the function is a template, and you specify what T is inside the brackets. Okay, so let's uncomment these. By the way, I worked really hard to figure out which parts should be commented, which parts should not. All right, so we have an int here, double string, int double. Okay, this is interesting. A vector of ints. So T is a vector of ints. And then the vector we're passing in is this. We're using uniform initialization 1, 2, and 3. We can also declare times. This is the start time, the end time class. Okay. Start running that. I did not print min max for the vector, but I did print it for the time, and you'll see something interesting. Okay. So let's see. This is all fine. What do you notice here? Oh, wait, sorry, this one. What do you notice here? This is correct. Okay, something weird's going on, right? Okay, min, max 3, that makes sense. 2 and 2.3, that makes sense. Time, it even figures out that 3:30 is before 4:20. Okay. Now, just a side note. The only reason this compiles is because if you look in templates.h, I defined what it means to compare 2 times. Because C++ doesn't actually know what you mean by comparing times. I actually defined these here. We're not going to talk about these yet. We'll talk about them in a couple of weeks. But the thing is, you can compare times if you tell C++ explicitly how to compare times. Okay? So, any questions? Everything makes sense so far? We don't have too much to cover today, so we can walk at a leisurely pace. Question? Yes.
So if we remove that line, template, type name T, just because we are already mentioning the kind of variables that we are using inside the function, will that work?
Are you saying remove this part?
Remove template, type name T.
This one?
Yeah.
Okay. The problem with that is then C++ doesn't know that T is not a real type. It's a template. It's like a template parameter. So you have to explicitly say it's a template for it to say, oh, okay, T is not a real type. It's something that will be filled in later when you call a function. want more candy?
I know this might be kind of general, but could you just like define a template? Templates in general, like what is a template, and like how is it internally structured? Like what is it meant to do?
Okay,
Yeah.
good question. So today we're going to mostly focus on template functions. So we're only going to templatize functions. Yeah, there are more things you can templatize, but that will require a little bit of a deeper knowledge of process. So we'll cover that in a couple of weeks about template classes. Yeah, there are, and if you please do a search for me. There are many things you can templatize. Today we're going to mostly focus on the functions, but we will talk about what else can you templatize?
I guess what does it mean to templatize something?
It means to write whatever you're templatizing in terms of something that you don't know yet when you're writing code, but will be figured out when someone calls your function. So for example, let's quickly just run through, let's go to the slides again. All right, so for example, when you make the first call, MyMinimax double, when the compiler sees this, the compiler says, okay, MyMinimax, I know there's a function, and that function is a template. So it tries to say, okay, what is my t? T is double. So what it does is it takes that double and it replaces all the t's with doubles. And then code just runs like double. Interesting thing is this all happens at compile time. So when you compile the code, all of these functions, after like these functions that have the t replaced in them, they are all generated at compile time. Okay, this is a compile time thing where when you press compile, all of these functions are generated out of that template. And then when you, at runtime, everything is just the same, just as if we had written this ourselves.
Although note that only happens with explicit instantiation. When you do implicit, the one benefit is that, benefit or drawback is that it creates these functions at runtime. So you'll only ever get the functions that you end up directly calling in the code. So that can be a benefit if you say like had a lot of extra explicit functions in your code. It can be a drawback because it makes your compile time, it can be a benefit because it makes your compile time a lot shorter. A lot shorter, but it makes your runtime really slow.
Okay. Wait, because if you instantiate it with the wrong type, it won't compile.
It'll check it, but it won't generate the full function.
Okay. So, yeah, this is basically what it does. Question? Yes.
Can you give an example of how you use a template in like an int or a size c?
Because we will cover that later, so I want to cover that later.
Okay.
Okay. Another question, yeah, question over there.
I have two short questions. The first one is more of a vocabulary one. So you said that the template is the whole function, but I thought the template was the type. So the type t is that not a template then?
Okay, I need to get the vocabulary right. So the entire function is a template function. The function is a template. Is that wording correct?
It is so the entire thing is now just known as the function template. Like it's no longer even like a function.
Okay.
So what do we call t?
And then t is the template parameter. Parameter, right? Okay, template parameter. Yeah, because these are kind of like parameters. Right? You fill it in with something, and then it becomes what's in the function.
And second question, sorry, could you go back to the code? Thanks. If you scroll down more. Yeah, so if you wanted to put two different types, so double, like the first number is a double and the second one is an integer, how would we do this with a template function?
Oh, okay. So you're saying give two different types?
Yeah.
Yeah, we could do something like this. Let's call it T. Is that T? U? Okay. I know my alphabet. You could do something like that. So you're saying, okay, T is a template. U is a template.
So you put U in the whole pair thing.
Yes. Well, so the thing is, this doesn't make too much sense because then you're saying, okay, I can compare an int and a string. Like, how do you determine which one's the int, which one's the max? So, like, yeah. So, like, this function wouldn't really make sense because that allows you to compare different types.
Okay.
Yeah.
I thought you were just in general like showing her something, and that in general is
Yeah,
I
like
know that you were trying to apply it to like that function.
yeah. So the syntax is this. You can't really do it with this function because there is no like min and max between two different types. So, but the syntax would look like that, and we'll do that very soon. We might not get to it.
And so would you just add the second type when calling the function and the comma?
Yeah, exactly. Candy?
Sure. The one you gave me is unavailable.
Okay.
Yeah.
Okay. Yes.
So, do these type names follow the entire way down the file then? So if you have multiple functions in one file?
Yeah. It only follows the function.
That's
It's the
immediately
code.
next to it. Okay.
Okay. Any other questions? Oh, we have a lot of questions. Yes.
When you did the type name P and then type name U, can T be the same as U?
Yes. Yes.
My student, can you template functions?
Template function. Oh, as in like you pass in a function?
Yeah.
Yes.
Because then you could like have arbitrary functions taken like.
Yes,
Yeah.
that is the entirety of next lecture.
Okay.
Good question. Was there a question over here? Yes.
So, what's the reason why, why when you do the explicit instantiating, the value returned by the string function?
Good question. I was going to cover that later, but I'll quickly talk about it right now. So the reason is that the literal Avery, what's the type? So remember, it is a C string, right? Remember first week of 106 meter X, Cynthia talked about how C strings are different from strings themselves. The literal itself is a C string, okay? And comparing C strings is not a good thing. You don't really want to compare C strings, all right? So here the reason is because I declared Avery before Anna, so that's why the C string Avery is less than the C string Anna, okay? But one way we can fix that is if you explicitly say string, what it does is it looks at these C strings, but it says, wait, you want a string. T is a string, not a C string. So it converts a C string to a string. Good question. Andy?
Yeah, anyone.
Anyone? Okay. Yes. Yes.
So if we overload the function that you have like MyMinimax, so that you wanted to catch all you wanted as a catch all for every type except an int. And then you like overload it with another definition for an int. Which one would it choose if it compiles this way?
That's a great question. Okay, so wow, these are really good and really hard questions. So C++ has these things called when you create a template, what it does is it first looks at all the possible functions it can call. Okay, including all the templates, all the overloaded functions. I think it's called like the overloaded set or something. And then, so those are all the viable functions. And then it has a sequence of rules which determines which one's the best one it chooses.
Yeah, but in cases like this, when it's trying to figure out those clashes, in both functions specifically have the exact same signature. So how would it decide between those two?
There are a list of rules on CPP reference. Do you want to look at it right now? Okay. CPP reference template deduction rules. Okay. The short answer is don't do that because that's really confusing. But there's a list of rules which determines which one is the best template chosen. Okay, and it's terrifying. I don't understand any of these, but yeah. So if you don't explicitly say what the template is, then it follows these rules about how to figure out what the template is. All right. No one memorizes these, so yeah. And then it goes through all the possible types. Great. Yeah. So yes, there is like a structured way that it does it.
Okay.
Just don't do that. Any other questions? Okay, can we move on? Let's move on. If there are questions, that's we can talk later. Okay. Oh, this is harder than I thought. Okay. All right. Your job right now. Very short. Anyone recognize this function?
Get integer.
Yeah, get integer. So let's templatize it so that now instead of get integer, it's get something. Okay? So on your laptop right now, try to write it as get something. So basically templatize it. Instead of returning an int, make it return some arbitrary type that can be specified. As an example of how we're going to use this, oops. we're going to here. As an example of how we're going to use this, we're going to say, okay, get type value an int that will prompt the user for an integer. Get value type int, okay, get value type double, it prompts the user for a double. Get value type time, it prompts the user for a time. Okay, so try templatizing that right now. Should be pretty short. Alright, so what did you do? Anyone who hasn't gotten the piece of candy yet? Anyone want candy? Anyone want candy and have an answer? Sure.
So you declare the template on top.
Okay.
And
Okay. Template.
right, and then instead of int, you would use t as to get that value, and then in type ID int, you would change that to t
Okay.
as well. And I'm missing someplace.
Result.
Right, and result should also be t.
Okay.
Right.
And everything compiles. Let's try running it right now. By the way, you don't have to understand what the type ID does. I over the weekend, I spent so much time trying to make it so that it prints enter and int. But the thing is, my compiler does weird things with int, so it says I instead. Let's see, 3. Because I asked 2 ints. Okay, let's say we did 6.8 invalid format because it can't read. It knows that t is an int and it can't read 6.8 into an int. All right, 1, enter a double, 3.0. Enter it calls it a for time, and that's a struct. And then I specifically instructed it so that I can type in a time like this, and it returns.
Does it pick what type it is, or did you get to pick what type it was?
I picked what type it was over here. I said ask the user for an int, a double, and a time. Yeah, this is an explicit instantiation. Okay, let's skip a lot of the implicit instantiation part because there's not too much to cover. The only thing to cover is sometimes you have ambiguities, and that's where issues with implicit instantiation come in. So here, the compiler is smart enough to know that t here you mean 4.2, a double. T is a double here. Right? What's t over here? T is a C string. So this will not work. A couple things you can do. You can either pass in a string like this, so that converts it to a string, or you can explicitly instantiate it. Question, yeah?
What if you had like a situation where you might pass in like an integer or like a vector, so would you just always like pass it by reference, or is there one you choose after templatizing it?
Good question. So so just in case it's a large collection, I would do something like this. I guess there is a way where you can say if it's a class, so instead of typing but class, then it would pass it by reference.
Okay.
Yeah. But I think this would work for sure.
Okay.
Any?
Oh, no.
Okay, question.
So what happens if you pass in, like, for example, an int and a double to do the compare thing? Will it make both of them a double, or will it make both of them an int, or will it keep their types as is?
Good question. So here you'll see that it gives you a compiler error.
Okay.
Yeah. It says, okay, t is an int, but it realizes 2.3 is not an int, so that doesn't work.
So in this scenario, you would add another template name view or something.
Yeah, but you don't really want to do that for MinMax because that allows you to give non-comparable types like int and string. Yes.
Why won't it automatically pass the double to an int? Or the other way around?
Templates have special rules about like what specific castings you can do. Yeah. So I think it tries to be as strict as possible. When you're doing templates, it won't do any implicit conditions. Good questions. All right. So and then can you guess why this doesn't work? Why these two don't work? Oh, and this one doesn't work either. Why don't these work?
Vector.
Vector, time, and this is a patient struct, which if you've taken 106 already, you will know what that is. Yeah. Why don't those work?
What is it? Patient struct?
Yeah. Okay. First, just looking looking at it, do you know which one is a time? It's not super clear, right? Yeah, and that is kind of the point, which is it can't, we're using this uniform initialization thing, so it doesn't know what type it is. So you can't do it that way. Alright? Cool. Alright, let's comment these out. Let's quickly go to the next part. Okay, well, clearly we are not talking about the really fun stuff. Sporadic parameters. Talk to me if you want to learn more about it. Okay, let's talk about generic programming. So we're going to write generic functions. And why do we want to write generic functions? Generic functions, that lets us write a function that can be used in many different contexts. It's generic. It's flexible enough so that no matter what kind of questions you have, what different operations you want to do, you can solve it using a similar, like one single function. Okay? You can imagine how that is helpful. It repeats a lot of redundancies, and it also gives you just a very powerful function that can be used in just any context. For example, we're going to write one single function which can solve all of these. So count how many times something appears in something, count how many times 5 appears in the second half of a list, count how many times an element appears in the second half of a list, at most 5. Okay? There's this thing called concept lifting, which is essentially we are going to essentially start with a function, then we're going to question what assumptions we're making about the function. Okay? Using that, we're going to try to add templates to the function to make it more generic. Just as an example, take a look at this function. So this essentially counts how many occurrences of how many times does the integer value appear in a vector of integers. Okay, does that make sense? This function's pretty straightforward. All right. This function is making some unnecessary assumptions about its parameters. What in particular? Go ahead. Which one? Sure. So one thing you can look at is, okay, integer, does it have to be an integer? Can it be a vector of anything else? Okay, so that is one good assumption we can relax. And to relax that assumption, we can add a template to that. So instead of saying it has to be an int, we can say, okay, it can be an int of anything. So data type is over here, data type is there. Make sense? Aren't some of you Jerry students? Okay, I can't believe no one caught that. Yes.
So that it has to be a vector. Could you make like a struct thing?
Good question. So does it have to be a vector? Okay? Let's templatize that. So instead of a vector, you have a collection of a data type. Any other assumptions? Okay, yeah.
Just a question.
Sure.
Oh, sorry.
That's fine.
Oh, okay. Just a question, like, if you were iterating over like a map, wouldn't you have to use like an iterator instead of using size t for I equals 0?
Great. This code doesn't work. Why is that? Because if the collection was a map or a set, they're not indexable. You can't use size I equals 0, I less than size, I plus my size. You can't do that. And this is where the power of iterators come in, right? Iterators provide a unified interface for essentially going through elements in a set, or no, in any collection. Okay, so for example, if we use a list, lists are not indexable, so this will not compile. And the reason is because we're using this array notation that's not allowed in, it basically is only allowed in a vector. Okay, so one way we can solve that is, okay, we can use iterators. And here is a more generic type, which is, okay, instead of looping over indices, we're looping over iterators. All right, this still makes one more assumption. You see what the assumption is? Sure, yes.
That it's a const?
Const. Good point. So if it's a const, that means even if the thing you pass in is non-const or const, both would work.
Oh, I
Yeah.
see.
If you put it as non-const, then you can't pass in a const. You make a good point though. I should probably make data type doesn't have to be const, it's passed by value. But yeah, that's a good point. If we removed the const, then we couldn't pass in const collections.
Raise your hand.
Yes.
Is it assuming that the double equals works?
so let's see. Oh, does double equals necessarily work? Are you saying that that's is that a question, or is that like an assumption?
I'm just saying that are there cases where the double equals wouldn't work and you'd have to use a dot equals method?
Good point. Okay, so let's see. How do I answer that? Yeah, this function does assume that double equals works. I'm not sure whether we should use dot equals, because then the ints might not work. But we will talk about this probably next time, where the collection you pass it, the data type you pass in does have to be comparable. That is actually the later slides about implicit interfaces. Assumptions, yes.
Doesn't this assume you go through the whole collection?
Yeah, awesome. This assumes that we are counting through the entire collection. All right. Remember, if we looked at the questions before, there was one question which is, can we count how many are in the second half of the list? So, how can we do that? How can we instead pass in a range within a collection instead of just the entire collection itself? Yes. Oh, sorry for both of you. You raise your hand first. Yes.
Just pass in a pair. Just like,
Great. Well, let's pass in two iterators. So we have an iterator begin, iterator end, and a data type. Okay, quick question. Why, I named this input iterator. Why does it have to be an input iterator? Why don't I say random access input iterator? Yes.
Is it maybe because like what you talked about before, if you don't use the lowest level thing you need, so like random access iterator is a type of input iterator, but if you only need to iterate forward and you don't need to step an arbitrary number of steps, then you would just pass an input iterator.
Yeah. Good point. Yeah, because not all collections have input iterators, so that would limit our function to only work for the ones that have random access iterators. Okay. So for example, I was going to show you this, but we ran out of time. Which is here's one bad way to write the function. One bad way to write the function is this. This is a bad way to write the function. Okay, because here you can see, okay, we're looping over indices, and then we're trying to calculate begin plus some number. Essentially move that iterator ahead by a certain amount. This doesn't work because what does that assume about this iterator?
That it's a random access.
Yeah, it's assumed that the iterator is a random access iterator. We want to make sure we assume the least possible about that iterator. The only thing the iterator has to do is it has to be able to read the element itself. It doesn't have to do anything else. Okay, so that's why we specify, okay, this one should be an input iterator. Key thing, this is a name, so it doesn't enforce it. Okay, so you'll get weird compile time errors later. Okay.
like input iterator, random.
Good question, but I don't know. I don't think so. Oh, you mean like you mean here?
Or data, right? Yeah.
Yeah, you can do that if necessary. I'm just doing it. Yeah. Okay, so how do you solve this one? Concurrence is begin min. How do you solve this one? Okay, how do you solve this one? Yeah. And so on. Okay, yeah. If you wanted a second half, then you would pass in the middle iterator and fine. We can't solve this one yet because that requires a thing called a predicate, which is someone asked this question, you have to pass in a function. So we'll get to that next time. Mismatch is such a cool function. I discovered it over the weekend, but we won't have time to get to that. Okay, so yeah, basically we kind of covered basically what we wanted to cover today. Okay, I was thinking maybe we might get to this, but if we don't, that's totally fine. We'll start with this next time because this implicit interfaces basically goes upon a lot of your questions, which is like, what are we assuming about different types? What do we assume about the type that is passed? So because of that, that's why we want to think about this. Okay. So next slide is really cool. Cynthia did a Hamilton example in the first day of class. I'm going to do a better Hamilton example. Okay. So yes, I'm going to write a program which censors all the bad versions of Hamilton, and I'm not going to use a single bullet. Okay. Not a single bullet. All right. If you want candy, come on up and get candy. Thank you guys. When we write templates, we want to make it work for all our templates. So to make sure that it works for as many times as possible. All right, so yeah, so you want to choose the.
Wait, oh, Eddie.
Do you want to? I'll just go outside.
Yeah.
Wait, Anna, don't just go outside. Let's just go outside. Okay, let's do here. So be careful. I don't want to drop my phone on this concrete floor. Okay. All right, go ahead.
Right thing. Input it right.
Yeah. So